Continuing my talk from the past video, we uh, completed the vibration of air column in the first one, that is a pipe opened at one end. Now we have to discuss the second one, which is pipe opened at both the ends. Let us see what happens in the first mode of vibration. So this is the tube, so I should not close it, right? So I should keep open the tube at both ends. As I said in the previous case, I am using a tuning fork, and let me assume this tuning fork will resonate this air column for a particular frequency f1, and that frequency, the waves of that frequency will produce a kind of standing wave here in the tube, like this. Okay, so like this. This is the incident wave, and then the wave will reflect at the open end, and it goes back. It goes back. Here is a antinode, and here in the middle is a node, and again at the open end at the top we are having antinode. So this is a lambda by 4 from antinode to node, and again lambda by 4 from node to antinode. In total it is lambda by 2. Since it is first mode, I write it lambda 1. The length of the tube is as usual, it is L. So what I can write for L then? L should be equal to lambda 1 by 2. Okay. So then lambda 1 becomes what? Lambda 1 is 2 times L. This is the wavelength that is possible in this tube, the first wavelength. Okay. So this is the first wavelength. This is in first mode of vibration. The first mode of vibration, right? So this is the corresponding wavelength. Now fundamental frequency, otherwise first mode frequency, fundamental frequency or first harmonic, right? First harmonic is what? Is f1, which is equal to what? V divided by lambda 1. We already know what to do for lambda 1. Lambda 1 is 2 times L. So which means what? F1 is equal to V divided by 2L. So this is what we got, the expression for f1, which is the fundamental frequency. You must know that V is a constant, right? So V is equal to this is a constant term, a constant, which is a speed of sound, right? So speed of the wave, speed of the wave or the sound, right? Sound in air column, which is a constant. Okay. So now further, what I can do here? So now I can write for the second mode of vibration. I will show you here the second mode. In the second mode, okay. So now we are discussing second mode of vibration. In the second mode, again I am having the same tube, which is opened at both ends. I am using different tuning fork. It is not same. Okay. So it is a different tuning fork of frequency f2, and this vibration will perform a kind of wave inside the tube. Okay, so that is could be like this. It is somewhat difficult. Then this one is the incident wave. When the wave gets reflected, you will get some standing wave in this way. This is the standing wave. Okay, so here one antinode is here, node is here, antinode is here, node is here, and again antinode. So 1 times lambda by 2, yeah, 2 times lambda by 4, say, or sorry for that. So here it is lambda by 4, one more lambda by 4, one more lambda by 4, one more lambda by 4, 4 times lambda by 4, right? So 4 times lambda by 4, which is nothing but what it is? It is complete wavelength, which is lambda. Otherwise, I can also write it as 2 times lambda by 2. For the second mode, I use the term lambda 2. Obviously, our length of the tube is still L. So then what I can write? L is equal to 2 times lambda 2 divided by L. Of course, I can even cancel these two, but in future I need these two to compare with F1 and F2. So I am keeping these two in the numerator as well as in the denominator as it is. Okay, so now solve for lambda 2, so which gives me lambda 2 equals 2 times L divided by 2, the wavelength corresponding to the second mode of vibration. So now the frequency corresponding to the second mode, the frequency for this mode, right, for this mode, which is the second harmonic frequency, right, second harmonic frequency, which is F2, which is equal to what I should write? It is V divided by lambda 2, or F2 is equal to V divided by, so what is lambda 2? Which is 2L by 2. Make some manipulations again. So which is F2, that is equal to 2 times V divided by 2L, put a bracket. Let us learn what is V divided by 2L. Go back. V divided by 2L is our F1, the fundamental frequency corresponding to the first mode, right? So which implies F2 is equal to 2 times F1. So this is the frequency corresponding to the second mode or second harmonic. Now we have to discuss the third mode of vibration. Okay, so let me have third mode of vibration. In the third mode of vibration, I am having the same tube again, same tube. So I am using a different tuning fork. It is not the same. Different tuning fork of frequency F3. Let me assume this F3 will resonate this tube. So under this circumstance, I should get some wave like this. This is the incident wave. And now the reflected wave should go like this, you know. This is the way how I may get the reflected wave. The dotted line indicates you the reflected wave. Okay. So now what I have to do is, sorry for that, where it went. Yeah, it is here. Let it be. Anyhow, here is an antinode. Here is a node, antinode, node, antinode, node, antinode. You must be aware at the both ends we must get antinode. Open ends are always with antinodes. So lambda by 4 one time, lambda by 4 two time, 3 time, 4 time, 5 time and 6 time. Right. So 6 times lambda by 4. So this is definitely equal to 3 times lambda by 2. So this is corresponding to the third mode. So I am using the subscript lambda 3. This is my L, the length of the tube. So now solve for lambda 3. So what is lambda 3? Lambda 3 is 2 times L divided by 3. This is the wavelength corresponding to the third mode of vibration. When you think for the frequency corresponding to this mode, frequency for this mode, otherwise we call it third harmonic. Okay, be careful. The second harmonic is the first overtone, and the third harmonic is second overtone. Okay, so second overtone, otherwise third harmonic for third mode vibration. What we write? We write F3 equal to V divided by lambda 3. What we are having for lambda 3, which is F3 equal to V divided by 2L by 3. When you rewrite this, we will get F3 equal to 3 times V divided by 2L. Put a bracket. And this bracket is again the same, which is the first mode frequency. V divided by 2L is here, which is the fundamental frequency. So we write it as F3 equal to 3 times F1 is the frequency corresponding to the third mode of vibration. Now look into all the three results. F1 is V divided by 2L. Otherwise, I can write F1 equal to 1 times F1. I think there is no objection, right? So F1 is equal to 1 times F1. F2 equal to 2 times F1. And what is F3? F3 is 3 times F1. So now in general, what we can write? In general, I can write F1 is to F2 is to F3 as how? It is 1 is to 2 is to 3. This is the theory about the first three modes of vibration in an open air column.